There are many situations in which ultrasound is performed. Perhaps you are pregnant and your obstetrician wants you to have an ultrasound to check on the developing baby or determine the due date. Maybe you are having problems with blood circulation in a limb or your heart, and your doctor has requested a Doppler ultrasound to look at the blood flow. Ultrasound has been a popular medical imaging technique for many years. Have you ever thought about how these machines work? In today's video we are going to see the 3D animation of how ultrasound works. So, let's get started. The heart of most ultrasound systems is a device called a transducer, which uses an array of piezoelectric crystals. The working of a piezoelectric crystal is that it vibrates when an electric signal is applied, producing high-frequency sound pressure waves, which we call ultrasound. More importantly, this type of crystal can also work in reverse. It can produce electrical signals when it detects high-frequency sound pressure waves. This device has many applications like producing sound from electric signals, getting sound and converting it to electric signals. This is the basics of the working of sonography. The sonography device has a transducer which we can see here. This transducer directs ultrasound waves into the body. They pass right through the skin and into the internal anatomy. As the waves encounter tissues with different characteristics and densities, they produce echoes that reflect back to the piezoelectric crystal. This happens more than 1,000 times a second. Returning echoes are converted to electric signals by using piezoelectric effect, which a computer converts into points of brightness on the image, corresponding to the anatomic position and the strength of the reflecting echoes. A medical transducer contains a large array of crystals which allow it to make a series of image lines that together form a complete image frame called a sonogram. The process is called sonography. In addition, all the crystals are repeatedly activated many times in such a way that a complete image frame is formed around 20 times per second, so that real-time motion is displayed in the ultrasound image. In addition to showing anatomic structures, functional ultrasound shows color image maps that can indicate the softness or hardness of specific tissues, movement and velocity of tissue or blood, and other physical characteristics. One type of functional ultrasound is Doppler ultrasound. If you've ever listened to how a siren sounds as it approaches, passes, and drives away, you were hearing what's called the Doppler effect. The waveform is compressed as the ambulance approaches, making it sound higher pitched, and it's stretched as the ambulance departs, making it sound lower. Doppler ultrasound uses the same principle to determine the speed and direction of the blood inside your arteries. The transducer is held at an angle to the blood vessel, and the altered frequency of the echo returning to the transducer from the blood flow tells the computer the speed and direction of blood. This information is displayed as different colors on the final image to show changes in or absence of blood flow, indicating blocked or narrowing blood vessels, decreased circulation, heart valve defects, blood clots, bulging arteries, or even the presence of new blood vessels and flow in tumors. Another form of functional ultrasound, elastography, can be used to differentiate tumors from healthy tissue based on the tissue's relative stiffness. Healthy tissue and benign tumors tend to be compressible, unlike malignant tumors, which are more firm. This compression was originally done manually, but newer elastography systems send out high-pressure pulses that compress target tissues by a predefined amount of force and display the resulting compression levels in various coded colors. By analyzing these colors, doctors can tell the difference between the healthy tissue and tumors. This was a brief about the working and the various applications of ultrasound. Guys, don't forget to share your thoughts in comment section below. I do read each and every comment. Thank you for watching. If you liked the video, don't forget to hit that like button and subscribe Science Seco for more amazing content.